Good morning, everyone. Sorry I'm not here today. This was planned. My son has a college visit down in Montgomery, Alabama. But anyways, you just watched a quick video over kind of the basics of what E is. So with that in mind, we're going to learn a little bit about this. I've kind of mentioned this before when we started logarithms, and I talked about that button on the front of your calculator, LOG, and how base 10 was used so often in science and in numbers and math that they went ahead and dedicated a special button to anything that's base 10. So the LOG button is definitely logarithm, but it's understood base 10. And we talked about how you could make anything, any logarithm base by using alpha window number 5. And that's kind of what we dealt with last week. Well, E, E is a number that was seen so much in the natural world that they also decided to make a special button in the front of your calculator that's designated specifically to logarithms that deal in base E. So the LN button in your calculator is just that. It is logarithms just like any other logarithms, but it's logarithm that is understood base E. I hope that makes sense. People think because it's LN that it's something different, but LN, I don't know exactly why it's backwards. I don't know if it's Greek, but think of it as natural logarithms, LN backwards, okay? NL, LN, natural logs, base E. So anytime we're dealing with exponential equations that deal in base E, which we're going to deal with some of those really soon, continuously compounded interest is one. It deals with the value of E, and therefore, because we're dealing with exponential equations, to solve it, when we want to rewrite it as a logarithm, we're going to use the logarithm that is base E, Ln. We'll talk more about that, but today we're going to kind of hit the basics of this, and then you're going to have a pretty quick assignment and should be able to finish it within this class time, even watching both videos. So what is E? E is, like they mentioned, it's a lot like pi. It's a mathematical constant. A mathematical constant, meaning it always stands for the exact same value. And again, that value is a estimated value, which that estimated value is 2.71828. Okay? Now, real quickly, I want to take you to our calculator because I want us to see this button. There's two ways to get to it. The first one I'm going to show you is second divide. See it right there, E? If I just push that, then sure enough, 2.718281828. Now, it looks like that 1828, it's going to be repeating. It's not. It changes, as you guys saw earlier. There is one more one more place you can find E, and that's second Ln. See it right there? But it's already raised to an exponent, so that one is just if you're quickly going to raise E to some power, you can do it there. So that is the E button in our calculator. Let's go on back to our notes. E often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. One of them, of course, has to do with compound interest, which we talked about not only a minute ago, but in that video he mentioned how they figured out what E even was. Now, when we talk about base E exponential functions, what we mean is an exponential function that is base E, they are called natural base exponential functions. And here's how you know you have one. Here's an example of the one I mentioned a minute ago. It is in function notation, a of t equals p times e to the rt power. This is called compounded continuously, or continually compounded interest. And I want you guys to notice something because you see multiple variables here. But remember when we talked about exponential equations, we said you have an exponent that has a variable in it, and then the base is immediately below it. E is the base of this exponent. P is being multiplied by it. It's not a part of the base. E is the immediate base of that RT exponent. So E, this is a natural base exponential function, compounded continuously. We'll talk more about how to work with this equation starting tomorrow. Maybe not tomorrow, it might be. Yeah, it'll probably be tomorrow. But again, this is what a natural base exponential function looks like right there. Now, when we talk about base E logarithmic functions, you're actually not going to see the base E at all. See, logarithmic functions that are base E, we call those natural logarithms. And you're not going to see E at all. Let me explain. The equation will look something like this. F of x equals ln of x. So you don't see any E. You see ln, which represents natural logarithm, but let me explain why you don't see E. When you see ln, you know immediately that your base of that exponent is understood to be base E. Just like log on the calculator, or if we were to write over here log base x or log of x, we know that this is understood to be base 10. Well, just like that, when I see ln, I understand it's understood to be base E. So these are your natural base exponent, and these are your natural base logarithms. So we refer to them as natural base, but exponents, but we refer to this as natural logarithms. And the ln obviously is the big giveaway. So if I'm going the opposite direction, listen, I want to show you the wrong way, so please don't write this first. You could absolutely write log base E. Remember, the base of your exponent becomes the base of your logarithm. And then you could do the loop. So log base E of 24 equals x. And if you wanted, you could go to alpha window number 5. You could insert base E, and then you could put 24, and you could push equals. And I promise you, it would be the exact same value as me understanding that because this is base E, I'm actually going to write natural log understood base E of 24 equals x. So now, of course, I can go directly to the home screen of my calculator, and I can type in ln of 24. Now let me prove it to you while I've got this calculator up and open. If I did alpha window number 5, and I plug that base E into that spot down here, and I raise this to the 24 power, notice it's identical in the value. These are the same thing. ln is simply understood to be base E. It's still logarithm in the same manner that log base E of 24 is 3.178. The natural log of 24 is 3.1782 because ln indicates base E. I hope that makes sense. It sounds confusing when I'm trying to say it, but it actually is just very simple. So here's what I want you guys to understand. When I see a base E exponent and it wants me to write it in logarithmic form, I know I'm using ln. I still do the loop. ln of what? ln of x equals what? 9. See, I'm still doing the same loop we did in the previous lessons. It's just when I see base E, I know I'm using natural log. And then I'm doing the loop. Natural log understood base E of 72 equals x plus 5. And that's how you rewrite these, just like we did before The only difference is because they're base e, we're using natural log, and we don't have to indicate the base because it's understood base e. So same here. We come across number 4, and all of a sudden it says natural log of x equals 58. Write it as an exponent. Well, remember, you're supposed to take the base of your logarithm, and it becomes the base of your exponent. Well, that's base e. And then you still do the loop. E to the 58th power equals x. That's how easy this is, y'all. So on number 5, what's the base? Base e. Do the loop to the x equals what? 6. And then number 6, ln, so I know it's understood, base e. Do the loop, raised to the 32nd power equals x minus 9. So very simple. Okay, let's not make it hard. All right, we could make this harder than it is, but I'm asking you not to. Okay, it's easy. Let it be easy. Don't make it confusing. So let me explain a couple things. Still, same rules in solving. If log equals log, you drop the logs. Whoops. I'm good at writing. If log equals a number, then we're going to write it as an exponent. I like to say exponentiate. Not 100% sure it's a word. I think it is. So look at number 7. Yes, it's ln. Those are logarithms, natural logarithms. So it's still log equals log. Drop the log. So you're still solving by taking 4x minus 27 and simply setting it equal to 15 minus 2x. Same thing we've done already. So I'm going to move my smaller x. Well, that's clear the negative 2x, so I'm going to add it. So 4x plus 2x is 6x, minus 27 equals 15. I'm going to add that 27, so 6x equals 42. And then I'm going to divide by 6, x equals 7. See? Same thing, y'all. Same thing. So those are very simple. Now let's look at 8. Is this log? Yes. Natural log. Is it log equals a number? Yes. Is the base and its argument isolated? Yes. Then we're ready to write it as an exponent. The base of my log, guys, what is that? The base of my log is e. And then I loop it. E to what power? The second power equals what? 8x. So I'm going to go to my calculator. I'm personally going to use this one since I'm raising it to the second power. And then we're just going to round to a couple decimals. Actually, if you look at this one, it looks like this is a great spot. Okay, if you want to do here, I'm okay with that. But personally, I'm going to go 7 point. You know what? I'm going to stay consistent. I'm going to do 7.39 equals 8x. So if I take 7.39 and divide it by 8, which I'm going to show you this in a minute, that's going to narrow down to 0.92 equals x. So let me show you this work. Again, I typed this in the calculator at 7.39 divided by 8.92. That's how easy this is, y'all. This is not new. Okay, I know that we're dealing with a new concept, E, Euler's number. I know that it's a different look for a logarithm, but the rules that we applied to the regular logarithms we just did last week, we're applying to here as well. So let's look at this, number 9. Again, I know this is a natural base exponent because the base of my exponent is e. So what I need to do is I need to first isolate that, and I do so by adding 6. So e to the y plus 3 will equal 2 plus 6 is 8. Now we're ready to solve this exponential equation. It's exponential. So again, just like we did before, and again, I can't make 8 have a base e, so we're going to solve an exponential equation by rewriting it as a logarithm. Okay, so this is still exponential, and we still solve exponential by rewriting it as a log. So because my base is e, I'm going to rewrite it as natural log, and then I'm going to do the loop. Natural log understood base e of 8 equals y plus 3. Now I can go to my home screen. I can use the ln button and do the argument 8. The natural log of 8 is approximately 2.08. And that equals y plus 3. So my last step here is going to be subtract 3. So I'm going to do 2.08 minus 3. And I get negative 0.92. Negative 0.92. I don't know why those ended up being 0.92 and negative 0.92, but there you have it. They are. And then the last one is, again, this is an exponential, this is a natural base exponential equation. How do I know? Because here's my exponent and the base is e. So we still need to isolate it, just like we did before. So subtract 7 to move that. These will cancel, and negative 2 times e to the x will equal negative 2. How do I break negative 2 away from e to the x? Well, it's multiplying. So I'm going to divide by negative 2. These cancel, so e to the x equals a positive 1. So how do I solve this for x? By rewriting this exponent, just like we did last week, as a logarithm. So since it's base e, I'm going to use ln, I'm going to do the loop, of 1 equals x. So I'm going to go to my calculator, I'm going to do ln of 1, push equals, and that is 0. X equals 0. And there's your work if you didn't write it down as we were doing it. So follow the steps. We subtracted 7, negative 2. Divided by negative 2, positive 1. I rewrote this as a natural logarithm, understood base e of 1 equals x, and the natural log of 1 is 0. And that's it, okay? That is how you understand natural logarithms and how to apply those in the same method that we did last week with normal logarithms. And I say normal logarithms. These are normal logarithms. They're just base e. Okay, they're the same thing as a base 3. It's base e, 2.71828. So the process of solving is all the same. So on the back you have your assignment. It's 12 problems. 1 through 4 shouldn't take really any time at all. And then solving these might take a little more time, but shouldn't be a problem. So tomorrow we'll go through this. If you have any questions, hold on to them and be ready to ask tomorrow. I hope you guys have a great Monday. See you tomorrow.